So basically,
Yeah.
uh, differential equation definition is equation which contains derivatives. It can be ordinary derivative or partial derivative or derivative of any order
Mm-hmm.
of unknowns, unknown function. For example, uh, dy over dx plus sin x equal to y. Now, y is unknown,
Yes.
but this
Yeah.
equation contains a derivative of the unknown function y. By solution, we mean to find y. Y is a function of x. What is that function of x which satisfies this equation? Is the solution. Okay.
Okay.
So here, in particularly in your case, in this exercise, he will be solving separable variable equations. There are a lot of types of equations. If derivative is of first order, the equation is called first order differential equation. As the derivative is of first order. If the derivative is of second order,
Oh,
we call
I see.
oh, it contains the highest derivative, which is of order 2. So this is called
Mm.
order 2 differential equation. Okay, first of all, in first chapter of the differential equation, we uh, encounter basically first order differential equations. And there are a lot of types of differential equations of first order, which are analytically solvable, which are analytically solvable. There are only
Mm-hmm.
a limited number of equations which we can solve analytically. Means we can find such y which satisfies the equation. Not all the cases. The first type of the first order differential equations which is solvable by analytical methods means we can find the exact solution
Mm-hmm.
is separable variable differential equation. What is that? By DE,
No.
I mean differential equation. Okay.
Mm-hmm.
What is separable variable differential equation? It has this form dy by dx. It has form like this dy by dx equal to some function of x times some function of y. This type of differential equation. Why we call it a separable variable differential equation? Because we can separate the variables in this equation like this. dy, if we take this gy to the left hand side, then it will be divided on the left side.
Mm.
And if we take this differential element to the right side, then this differential element will be multiplied on the right side.
Uh-huh.
So we say that we have separated the variables.
Mm-hmm.
After separating the variables, what we do, we just take integral on both sides.
Okay.
And the integral gives us the general solution. Okay, let's
Yeah.
see in particular case as given in this example number 25. Let's
Oh,
solve
so for
this.
that, just general
Sorry.
parallel and that kind of stuff. Okay.
Yeah. Suppose we want to solve this equation. This is a separable variable equation. So first of all, this is a differential equation because it contains a derivative of unknown function y. And
Mm-hmm.
we have to find the general solution for this equation. So what we will do, we will separate the variables. First step is separate variables. So here we have tangent y on the right side. Let's take it to the left side. So it will be 1 over 10y. Okay.
Mm-hmm.
and take this 1 plus x square to the right hand side, then it will be divided on the right hand side. So we will get x upon 1 plus x square. And differential
Hmm.
dx will also be multiplied on the other side. So we have separated the
Yeah.
variables. You can see on the left hand side, we only have y variable.
Yeah.
Okay. And we call y variable as the dependent variable.
What does that mean in a math context?
Dependent variable means y is function of x. Y depends upon x.
Oh, okay, I see.
Y depends upon x, so we call y as the dependent variable or the unknown function, and x is the independent variable. Okay, these are just names
I see.
for these variables. So after separating the variables, when you see on the one side we have only y, and on the other side we have only x variable, what we do, the second step is to integrate both sides. Okay, on the left side you integrate with respect to y. So we give element dy on the left side. So just give the integral sign on both the sides. So
Yeah.
why they put this after the 8 exercises of integration? Because it is connected with the integration. Solving
Hmm.
differential equation actually means integrating the equation,
Hmm.
because differential equation contains derivatives, and how to eliminate the derivatives, we apply the integration simply
Oh,
because
yeah.
these two processes are reverse of each other. That's
Hmm.
why. So how to integrate 1 over 10? We will bring 10x in the denominator, then it will become cot x.
Yeah.
What is the integration of this? You know this.
Uh, 2 times 1 plus x all squared.
No,
Oh, is it not?
no. Think about this.
Wait, when you have derivative of the function present at the top, you
Yes.
just if you
What is
equal
missing?
to
What is missing?
oh the two is
Just 2 is
missing. So
just 2 is missing.
no,
So what you will do, you will multiply 2 inside and divide 2 outside. That's it.
yeah.
So this is natural log of the denominator.
Mm-hmm.
And you give a
Oh yeah,
constant of integration. Every time you integrate, you give a constant of integration. What
yeah.
is the integration of cot x?
Oh man, sec x tan x.
No.
I haven't thought about integration in a minute. After that test, man, I just
Actually,
forgot
what is
all
the
of it.
problem? You know what is the problem? When you skip things, then you always get into the trouble. Now,
Yeah,
when you were discussing the integration of trigonometric function, you should do all these integrals in a sequence. You should know each of these integrals.
I remember the first like
You should know all of
the
them. You should not leave
I
any one. What is the integral
um
of sine x?
cos x. No,
No,
minus cos x.
minus cos x. What is the integral of cos x?
Sin x.
Yeah. What is the integration of tan x?
Um, I remember proving this. Wasn't it like ln? Oh yeah. Ln sec x.
What is
I
the
remember I told
integration
that.
of sec x? Sec x.
Sec x tan x. Oh, is it?
We have done it in these sessions.
Oh, that's not
What
sec
is the
squared. You're right. Um,
yeah, log of sec x plus tan x? What is the integration of cosec x?
more lns. Oh,
What is the integration of cot x? You
I don't
actually
remember
do it
any of
like
these. I remember the easy
uh,
ones, but not these ones.
what you do when you are integrating cot x, no problem. What is the integration? How you do integration of cot x? You use this formula. Cot x is cos x over sin x. This is very simple, man. Very simple. Okay,
Sin
can you
x.
write it?
So it should be, was it ln sin x?
Yeah, because derivative of denominator is present in the numerator.
Yeah.
So
I don't remember
your
the
knowledge,
single parts.
your knowledge
Just,
should be comprehensive. If you are skipping the things, you will definitely you will not be able to solve questions because
mm,
in any question this can come. Okay, then
yeah,
you
yeah.
will be you will be in trouble. You will be leaving this in between.
Hang on 1 second.
So
Just go back over just for
it
a
is,
second.
yeah.
Just so
You want to ask
there we go.
something?
I gotta make flashcards on that.
Hmm.
No, I just took a picture so I can make some flashcards.
What? We should
I
go
took
ahead.
a picture of flashcards,
Ah,
yeah.
yeah, 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 yeah. Okay. So I will share these slides with you.
Yeah.
So now, when you know everything is coming in the form of natural logarithm, so you should try to eliminate the logarithm from the solution. How you do it?
Uh, what do you mean remove the logarithm? Oh, make it.
So now you see this integration is coming in the form of logarithm. This is also logarithm. Then the constant of integration should also be in the logarithm form. So you do not give constant of integration as c, but log of c. You can do it because c is an arbitrary constant. C can
Yeah,
take
it can
any
be anything.
value. Yeah,
Mhm.
so you can put log of c
Yeah.
because everything is in log. You should put it log c. Now try to eliminate log throughout from this equation. How you will do it? You will try to uh, move this 1 over 2 towards in the power using power rule here.
Hmm.
Can I write it like this if you don't have any problem? Then, and you know, power rule brings this power
Yeah.
uh, in the front here. So we can use it in reverse, take it into the power.
Mhm.
So now we will use the product rule of logarithm because there is sum of two logs. We know that log a plus log b is equal to log of a times b.
Eight. Yeah.
And this is known as power rule of the logarithm. So I can write it in single log like this.
Hmm.
Fine.
Yeah.
Now what we will do, we will take anti-log in order to cancel this logarithm, both sides. Oh, where is y? It was not x, I think. It was y, right? On the left side, it was
Hmm.
y. On the left side is y. I made a mistake here. Left side was
Which if
y.
there's two things with logs, you can just cancel both the logs, yeah.
Yeah, yeah. So left side is
Oh,
y. So sine y is equal to c times 1 plus x squared. This is the general solution. What is the general solution basically? General solution definition is a solution which contains arbitrary constants.
uh, so that's why it's not
A
a definite
solution.
solution. It's just whatever C
Yeah,
is
general
fine.
solution means if we put a value of c, means this solution satisfies the equation, differential equation, irrespective of the value of c. Whatever the value
Hmm.
of c is, it will be a solution. So
Okay.
if we specify a value of c, for example, if we are putting c equal to 5, then that will be a particular solution for c equal
Uh-huh.
to 5, right? So it is
Yeah, yeah,
not a
I see.
general solution is not a single solution, but it is a family of solutions.
Hmm.
It is a family of solutions. For each value of c, we will have a different solution. which
Okay.
contains arbitrary constant. This is the definition of general solution. So a solution which contains arbitrary constants is called a general solution. So we have obtained a general solution here in this form, and this solution is uh, not explicit, but this is in implicit form,
Hmm.
right? Because x and y are mixed. So this is implicit form of solution we are getting here. We can get
Okay.
implicit or explicit solution, no problem, right?
Yeah, you can just take inverse sine of or sine of the
Yeah.
other side and then y. Yeah.
Yeah, let's see what is next. So again,
Or you can separate it, and then is there any different
yeah,
ones, or is it just you always separate?
same.
Okay.
L- Okay, what happened? Hmm. Why I am unable to paste it here? Okay, maybe it is he's pasting upwards somewhere here. Yeah, this is the problem. Let's take it here. Okay, this is the question. Now, what he says, sometimes you are interested in one specific solution to a differential equation. You
Hmm.
can find a particular solution to the first order differential equation if you know one point on a curve. If you know one point on a curve, then you can find a particular solution. This is sometimes called a boundary condition. So, if together with this
Oh.
equation, we are also given that when x is 1, y is 4.
Hmm.
This condition is called initial condition. He is calling it boundary condition, but in all other mature texts, we call it initial condition.
Hmm.
Okay, you can call it boundary condition, no problem. So
Upper
in
condition.
in
Yeah.
this in this example, he says that find the particular solution to this given differential equation. So what is the differential equation given to us here? Is this? Let me write the equation.
Plus.
This equation, and condition is when x is 1, y is 4. So first step is the same. You have to find the general solution first.
Hmm.
Okay. Then we will use the
Yeah.
initial condition or boundary condition to find the value of the constant and then put it back into the general solution. Then we will get the particular solution.
Hmm.
So first of all, first step is to separate the variables. So let's separate the variables. So we separate the variables in this equation? Yes. We can bring this y over 2 to the left hand side and dx to the right side. Variables will be separated simply.
Hmm.
So on the left side, you see there is only y, and on the right side, you can see there is only x and no y. Clear?
Yeah.
So what is the next step? Next step to integrate both sides. After separating variables, you need to integrate both sides.
Hmm.
What is the integral of this? Integral of 1 over y minus 2.
Just ln y minus 2.
Hmm. This is simple. What is the integral of the right hand side? How we integrate the right hand side?
Do we need to do partial fractions?
Exactly, partial fractions. So partial fractions, is a lengthy process.
Yeah, yeah.
Yeah, let me write down the partial fractions of this from the book. Let me
Hmm.
take it from the book, and I am just coming back.
Yeah, I've definitely done enough practice on partial fractions.
No, partial fractions are very easy.
Yeah,
You
yeah,
only
yeah.
need some practice.
Mm.
So again, he will paste that somewhere else. Let's find out. Oh yeah, yeah. These are the partial fractions. You see how
Yeah.
quickly I did partial fractions. So
Okay.
we just need to integrate now. You said the integration of the left hand side is simply log of y minus 2. What is the integration of the right hand side now? What is the integral of this? It is
Log of
log
x
of
plus 2,
x plus 2. What is the integration of this?
half of log 2x plus 1.
No, no, no. 2 is available
Oh, is it
in
not?
the numerator. Derivative is available
Oh, I
in the
thought,
numerator.
yeah.
Yeah. Now
Yeah.
you see everything is in logarithm. Everything is in logarithm. So you can, what you can?
Combine the logs
Yeah,
on the
but
right
what
hand
is the
side.
constant? You have to give the constant of integration. Should I add c or
Oh,
log of c?
ln c, log of c.
ln c. ln c is the constant of integration here.
Yeah, yeah, yeah.
Yeah. So let's eliminate logarithm from all of them. So I can write it as log of c times
X
x
plus,
plus 2 divided by 2x minus 1
yeah.
because the second term is negative, so it will be in the denominator.
Mhm, mhm.
So cancel this logarithm. So we have y equals to 2 plus c times x plus 2 divided by 2x minus 1. Is it clear?
Yeah.
Now here we are getting some explicit kind of general solution. This is general solution.
Mhm.
But we need particular solution here. So what do we do in order to find particular solution? We need to find the value of c here.
Mhm.
Find the value of c. How you find the value of c? We will use the given initial condition.
Yeah.
Given initial or boundary condition. There is a difference between initial and boundary conditions, but your book is not differentiating between them. So it's okay, no problem. You can call it initial or boundary, both. So
Mhm.
using given initial condition, what is that condition? It was given that when x is 1, y is 4. This was the
Yeah.
condition.
Yeah.
Let us check it in the question. When x is 1, y is 4. Yeah,
Yeah.
these
That's
are the
correct.
conditions. When x is
Mhm.
1, y is 4. Let's put these values. Put x is 1 and y equal to 4 in the general solution here. Okay. So
Yeah.
put y equal to 4 plus 2 plus c times 1 plus 2 divided by 2 minus 1. Let's
Mhm.
calculate the value of c now. So it will be 2 equal to c times 3. So 3 over 2 equal to c. 2 over 3, sorry.
Oh, yeah, yeah, of course, of course.
So after getting the value of c, what you will do now for the particular solution? So the particular solution is what you will do?
Just
You will
get
take
the general,
this
right?
just take the general solution. Just
Mhm.
take the general solution. This just take the general solution.
Oh no.
Take the general solution. What happened?
You unselected it. Yeah.
Just take the general
And you were
solution and
right?
yeah, yeah, no problem.
Okay, okay. Easy enough, easy enough.
I'm I am learning it. I'm learning this software. So this is the general solution and replace the value of C. Just replace the value of C. C is equal to
2/3.
what? 2 or 3. This is the particular solution.